I would thank Mr. Negi to give us an opportunity to make 10 or 15-minute technical discussions on the asset integrity of CGD networks. So I'll just show you one photograph, two videos, and then keep the time, respect, and give my talk for 10 minutes. So these incidences, what I'm going to show you, are real-life incidences, all happened in the last 6 months. At an average, in CGD networks, one pipe leaks every 6 months. Now, things don't come up. It's a different story. Mr. Negi is making a compendium of all the losses, of all the failures. In the last 3-4 years, sir, I'll give you a lot of data which you can include. Look at this photograph. 3 LPG coated pipeline, a huge lump. Recently, this fault was detected. LPG pipeline working at 60 bar pressure. LPG was leaking. During foot patrolling, the foot person who was doing the patrolling smelt and alerted the particular asset owner that there is a leakage of LPG from this particular area. Now, the next video, when the asset owner went in, excavated the pipe, they found the following. A small pinhole. This pinhole is something which is going, such pinholes are going to create major havoc in the Indian pipeline industry, whether it is products, CGD, LNG, natural gas, whatever. Why is this happening? This is basically AC interference. It's AC coupling between a high tension transmission tower running parallel to buried carbon steel pipelines with 3LP coating. So this was a small defect created within 3.5 years of the pipeline getting commissioned. 3.5 years. That's what the Indian pipeline is going to face. Another video. This is a real video. I don't know, I have passed it on to many of my colleagues. This happened on 17th of April in Gurgaon. A city gas pipeline blew out.
अभी कोई धूल नहीं है यहाँ पे.
धूल का कोई वो नहीं है यार.
सब गैस निकलेगी, फटेगी तो धूल उड़ेगी ना उसमें.
पहले भी लीकेज होता है.
In many more networks in India if we don't take care of it. Just let me describe to you sector 52.
Sound बहुत ज़्यादा होता है सर.
This is the house from where, fortunately, there was a CCTV camera which we could capture and come to a root cause analysis. What happened? All these cars were completely burned. House survived. The pipeline is below the green corridor, which are the tall trees. Now, once the red truck goes, just keep your focus on the treetop. You'll see a fireball on the treetop. The fireball comes, and now an explosion.
अब देखो फायर के साथ आपको धूल नजर आएगी.
Explode.
ये देखो
Now
ये
the
उठी
pipeline is
धूल.
exploding. All these cars.
अब धूल के अंदर से निकली आग.
This is in common domain. You can Google out and look for the incidents. Now, this should be an eye-opener today for the industry. Why did this happen? Even PNGRB was involved in this. I was involved, Mr. Tiwari was involved. So this fireball, then finally the video stops here, but all these cars get burnt off, it's in public domain. Now why did this happen? Number one, the pipeline was underneath a 220 kV transmission tower. The pipeline was operating for many years, and that's how failures occur today in the industry. People become complacent. चल रहा है, चलने दो, क्या है, कुछ नहीं होगा. But when it happens, fortunately there was no fatality here, but the cars got burnt. So I'll just describe the sequence of events very quickly. There was a flashover in the treetop. The fault current went through the tree, and the pipeline was at a depth of 2 meters under the tree. The transmission tower was running parallel over the pipeline, and the transformer footings were about 30 meters away from the pipeline. So the pipeline is running here, two transmission towers, transmission tower footings, and the 220 kV transmission running there. At that particular point of time, when this incident occurred at the 220 kV substation, which was 1.5 kilometers from the pipeline, there was a fault in the lightning arrestor. That fault, this is the theory what we developed, and the theory which was developed by the Haryana Vidyut Nigam was different. And then we had to prove that our theory was correct and Haryana Vidyut Nigam's theory was wrong. So when the fault occurred on the lightning arrestor, they were doing some maintenance. That fault created a heavy surge in the three-phase transmission conductors which were over the pipeline. The lowest conductor was the B phase, and we presume that due to the fault, the 220 kV voltage went up to probably 380, 390 kV. We did the mathematical calculations. That sudden surge caused the air gap, which was the air gap between the trees. The trees was almost touching the transmission tower lowest conductor. That caused the breakdown in the insulation of the air, and a spark caused a fault current now to flow from the conductor through the air, through the tree into the ground. The intensity of this fault current was close to about 10,000 amperes, because this is the fault level of the 220 kV substation, and the 220 kV substation was very close to the pipeline. Some of you, if you are electrical engineers, you will understand that if there is a substation very close to the pipeline, the source impedance is very low, so the fault current is very high. Now that 10,000 ampere went down the tree, it hit the ground. Ground has a certain resistance. So ground resistance, say, let's assume it's 10 ohms. So 10,000 into 10 ohms is 1 lakh volts. 1 lakh volt was generated in the ground in which the pipeline was laid. The pipeline potential is at 0 volts. So 1 lakh volt came in the soil. Pipeline is at 0 volts, and the distance was quite less from where the current went in, which was the tree. So an electrical arc in the ground was struck between the tree roots and the pipe. That 10,000 current entered the pipe. How did it enter? Because we first created a 1 lakh volt of potential. 3 LPE coating typically has a 20 kV per mm dielectric strength. So the dielectric strength was about 80 kV, 1 lakh kV, 80 kV. There was a puncture in the 3 LPE coating and the current went in. When the current went in, it created a 3-inch hole in the pipe. That's the time when the pipe blew out. That electrical current which entered now spread into the pipelines, and wherever you had nearby CNG stations, where the earthing was not done properly, the surge diverters blew out. So we have physical evidence that the surge diverters blew out, the TR units blew out. Now, the Haryana City Gas was the asset owner. Haryana Vidyut Nigam Limited was the electrical asset owner. They put the blame on Haryana City Gas and told them very categorically that there was a leak in your pipe which caused this mammoth fireball. The fire went up, melted the conductor fell down, and that created a short circuit. That was what they said in the first information report which was filed to the police station. We then did a complete analysis. Fortunately, this video helped us in reconstructing the entire thing, what happened. It was the problem at Haryana Vidyut Nigam Limited. Fortunately, from the open source, we picked up the time of the fault, when the fault occurred. We coincided it with the time which was coming into this CCVT. We then went into Haryana, to the Haryana Vidyut Nigam officials, spoke to them, they denied everything. We went up to the Power Grid Corporation and found out that whose circuit breaker tripped. Haryana Vidyut Nigams, when the short circuit occurs, the law says, as per CAA, the circuit breaker should trip within 160 milliseconds. Haryana Vidyut circuit breaker at 220 kV did not trip, lack of maintenance. The next substation, circuit breaker did not trip, lack of maintenance. About 100 kilometers away, the third main 400 kV grid substation of Power Grid Corporation, because all these electrical networks are interconnected, that breaker tripped after 1800 milliseconds. The break should have been after 160 milliseconds, complete failure on the part of the electrical authority. That 1800 millisecond caused so much of energy which led to the failure of this pipeline. So the lessons which come out from this incident is, this is the third incident which I have seen in the last 3 years when I have been deeply involved in looking into the risks of CGD networks vis-a-vis AC interference. So the quick learnings are, number one, the asset operators need to understand the significance of a close proximity hydrocarbon pipeline with a high voltage transmission system. Nobody understands. Today still 99% of the CGD operators, they will talk, but there is no action at the ground level. Why there is no action at the ground level? What are they going to do? They have already laid pipelines which are in close proximity. In June of 2023, Central Electrical Authority issued a gazetted notification that pipeline, any hydrocarbon pipeline cannot be close to any high voltage transmission system in a limit of 25 meters. That means you have to keep your pipeline 25 meters away. That's the law. So what are the city gas operators going to do? Are they going to shut down their networks? They will have to do, because that's the law. If one person dies, who will be held responsible? There was a valid question raised by my colleague here that in the basement, if you have a CGD connection coming in and if you can't ventilate it properly. But these are things which are today in the public domain. Either we sleep and close our eyes, sir, or we do some action. So this is the reality. The presentations are there. I've got many other presentations to show what is happening. But shortage of time, I just wanted to emphasize to all the senior leadership sitting here, and it was also said, sir, during the opening session by all the eminent speakers, people are realizing, the senior leadership of the CGD companies are realizing, but are they acting? The actions are very, very limited. We still want to think that nothing will happen, but do remember, if things go wrong, they go wrong very bad. This incident of what we have seen in Haryana City Gas is one of the incidents. There are many such incidences which we are now seeing today. So my sincere request to the entire team is that we should all get very serious. The companies have to understand that they have now started playing with fire. 10 years back, it was a different story. 5 years now, as we go forward, the electrical interferences on our pipelines are going to increase dramatically. Are we prepared today? Answer is no. Do we have to be prepared? Answer is absolutely yes. So with this, I'll close my presentation. Any other questions, we can talk subsequently. Thank you very much.